Picture this. It's a morning like any other. The sun rises over a vast coastal plain. The air is warm, humid. The sky is clear, a brilliant blue. In the distance you can hear the calls of creatures moving through forests of ferns and conifers. A herd of Triceratops grazes near a river, their three-horned heads lower to the ground as they strip leaves from low-growing plants. Nearby, a young Tyrannosaurus rex watches from the tree line. She's hungry, calculating, but the Triceratops are too large, too dangerous. She'll wait for a weaker target. In the sky, Pterosaurs soar, their wings span meters across. They dive toward the water, snatching fish in their beaks. On the ground, small mammals scurry through the underbrush. They're the size of rats, nocturnal creatures trying to avoid the heat and the predators. The world is alive, vibrant. It has been this way for millions of years. Dinosaurs have ruled the Earth for over 160 million years. They've evolved into thousands of species, giants and small hunters, herbivores and carnivores, creatures adapted to every environment. This is the late Cretaceous period. The date, if we could mark it, is approximately 66 million years ago. The location is what will one day be called North America, but the continents are in different positions. The climate is warmer, there are no ice caps, sea levels are higher. Everything is normal. The dinosaurs don't know that in a few hours everything will change, that this day will be their last, that an event is already in motion that will end their reign and reshape life on Earth forever. Because right now at this very moment, something is approaching, something that has been traveling through space for millions of years, something massive, fast and utterly destructive. An asteroid, 10 kilometers wide, racing toward Earth at 20 kilometers per second. And when it hits, the age of dinosaurs will end. This is the story of that day. The day the dinosaurs died, 66 million years ago. Let me take you through it, hour by hour, moment by moment, what happened when the asteroid struck, how the world changed, and why after 160 million years of dominance, the dinosaurs were gone in an instant. To understand what happened on that day, you first need to understand the world as it was in the late Cretaceous period, about 66 million years ago. The Earth looked different. The continents were still moving, slowly drifting to the positions we know today. North America and Europe were separated by a widening Atlantic Ocean. South America and Africa had split apart. India was an island, drifting north toward Asia. Antarctica was still connected to South America and Australia. The climate was warmer than today. There were no polar ice caps. Sea levels were much higher, flooding low-lying areas and creating vast shallow seas. Forests grew where deserts are now. The overall temperature was perhaps 10 degrees Celsius warmer than today. And in this warm, lush world, dinosaurs thrived. They had been the dominant land animals for over 160 million years. To put that in perspective, humans have existed for only about 300,000 years. Dinosaurs ruled for more than 500 times longer. There were herbivores like Triceratops, with their massive frilled heads and three horns, hadrosaurs, duck-billed dinosaurs that traveled in herds and may have cared for their young, ankylosaurs, armored tanks covered in bony plates with club-like tails. There were carnivores, Tyrannosaurus rex, one of the largest land predators ever to exist, with bone-crushing jaws, velociraptors, smaller but intelligent pack hunters, Spinosaurus and many others. In the oceans there were massive marine reptiles, mosasaurs, some over 15 meters long, apex predators of the seas, Pleidnosaurs with long necks, giant turtles. In the skies, pterosaurs soared, Quetzalcoatlus, with a wingspan of 10 meters, the largest flying animal ever known. But dinosaurs weren't alone. Small mammals existed, mostly nocturnal, hiding in burrows and crevices. Birds had evolved from small theropod dinosaurs, and were diversifying. Crocodiles, turtles, snakes, frogs, insects, and countless other forms of life filled every niche. The world was teeming with life, complex ecosystems, predators and prey, plants and herbivores, everything balanced, evolved over millions of years. And then on one ordinary day, everything changed. The asteroid that killed the dinosaurs didn't originate near Earth. It came from the asteroid belt, a region of space between Mars and Jupiter where millions of rocky fragments orbit the Sun. These fragments are leftovers from the early solar system, about 4.6 billion years ago. When the planets were forming, not all the material came together. Some remained as asteroids, chunks of rock and metal ranging in size from tiny pebbles to dwarf planets hundreds of kilometers across. Most asteroids stay in the belt, orbiting peacefully, but sometimes collisions happen. Two asteroids smash into each other, fragments are thrown off, orbits are altered, and occasionally one of those fragments gets knocked onto a path that brings it closer to the Sun, closer to the inner planets, closer to Earth. This particular asteroid was about 10 kilometers in diameter, roughly the size of Mount Everest. It was made of rock and metal, dense and solid, and it was traveling at about 20 kilometers per second, that's 72,000 kilometers per hour. It had been traveling for millions of years, perhaps longer, a silent cold rock drifting through the void. No one was there to see it, no one could stop it. And 66 million years ago, Earth's gravity pulled it in. Let's imagine the final moments before impact. The asteroid enters Earth's atmosphere. At 20 kilometers per second, it crosses the distance from space to the surface in less than a second. There's no time for anything to react. As it enters the atmosphere, it compresses the air in front of it. The air heats to tens of thousands of degrees. The asteroid itself begins to heat, but it's moving too fast to slow down or burn up. Smaller meteors burn up in the atmosphere. This one is too big. It punches through. The sky lights up. For a brief moment, it's brighter than the sun. Anything looking up would be blinded instantly. But there's no time to look, no time to process. The asteroid strikes. The location is what we now call the Yucatán Peninsula in Mexico. At the time it was a shallow coastal sea. The asteroid hit just offshore near the modern town of Chicxulub. The impact releases an unimaginable amount of energy. Estimates suggest it was equivalent to about 10 billion Hiroshima atomic bombs. Some scientists say 100 billion. The numbers are so large they're almost meaningless. Let's just say it was the most violent event to occur on Earth in millions of years. The asteroid vaporizes on contact. The ocean water at the impact site vaporizes instantly. The rock beneath, limestone and other sediments, vaporizes. A crater begins to form. In the first second, the crater is already 30 kilometers wide. In the first few seconds, it expands to over 100 kilometers. The final crater, once the ground rebounds and settles, is about 180 kilometers in diameter. That's wider than the entire state of Connecticut. The energy of the impact sends a shockwave through the Earth. It's like ringing a bell, but the bell is the entire planet. Seismographs, if they existed, would register an earthquake of magnitude 10 or higher. For comparison, the largest earthquake ever recorded by modern instruments was magnitude 9.5. This was far beyond that. The ground shakes violently. Hundreds of kilometers away, the shaking is strong enough to knock over trees, collapse hillsides, trigger landslides. At the impact site, the rock is instantly melted. Molten rock and vaporized material shoot upward in a massive plume. This material, called ejecta, is blasted out of the crater at incredible speeds. Some of it is thrown so fast that it escapes Earth's atmosphere entirely, reaching space, but most of it arcs up and then falls back down. Within minutes, chunks of rock, some the size of cars, some the size of houses, begin raining down across North America and beyond. These are traveling at thousands of kilometers per hour. When they hit the ground, they hit with tremendous force. They're glowing hot, heated by their passage through the atmosphere. Imagine a meteor shower, but instead of small streaks of light, it's boulders, and they're falling everywhere. And as this molten rock falls, it ignites everything it touches. Forests burst into flame. Grasslands ignite. Within hours, massive wildfires are raging across the continent. But the falling ejecta and the fires are just the beginning. The impact occurred in a shallow sea. When the asteroid struck, it displaced an enormous volume of water. Trillions of tons of water were pushed outward in all directions. A tsunami formed, not a normal tsunami, a mega-tsunami. The initial wave was hundreds of meters high. Some estimates suggest it could have been over a kilometer high near the impact site. This wall of water radiated outward at hundreds of kilometers per hour. Within minutes, the tsunami reached the coastlines of what is now the southern United States. The water surged inland, inundating everything. Forests, plains, river valleys, all were swept away. Dinosaurs, animals, plants, anything in the path of the water was destroyed. The tsunami traveled across the Gulf of Mexico, striking the coasts of Texas, Louisiana, Florida. It crossed the Caribbean, hitting islands and coastlines. It may have reached as far as the eastern seaboard of North America and even Europe and Africa, though it would have been smaller by then. For creatures living near coasts, there was no escape. Even those inland near rivers connected to the sea were not safe. The water surged up rivers, flooding valleys far from the ocean. In the hours after the impact, entire ecosystems along coastlines were obliterated. Millions of creatures died. Forests were uprooted. Sediments were churned up, burying everything under layers of debris. While the tsunami was devastating, it was localized to areas near oceans and coastlines, but the effects of the impact were about to become global. Remember the ejecta, the molten rock and debris blasted into the atmosphere. Much of it went up tens, even hundreds of kilometers. Some of it reached the edge of space. This material didn't just fall back down immediately. It spread. Carried by the upper atmosphere, and by the sheer force of the explosion, it dispersed around the world. Within hours, ejecta was falling across the entire Western Hemisphere. Within a day it was falling globally. And as it fell, it brought fire. The debris re-entering the atmosphere heated up, friction with the air caused it to glow red hot. Imagine billions of meteors, all falling at once, all over the world. This radiated an immense amount of heat. The sky itself seemed to be on fire. The temperature on the ground spiked. Estimates suggest that in some areas the surface temperature may have risen by tens of degrees within minutes. Plants ignited, forests, grasslands, anything dry or exposed burst into flames. Animals that weren't incinerated immediately sought shelter, underground, in water, anywhere to escape the heat. The wildfires spread rapidly. In North and South America, entire continents were ablaze. Smoke and ash filled the air. The sky, which had been clear that morning, was now choked with black clouds. And this was happening everywhere. Europe, Africa, Asia, Australia. The entire planet was experiencing the same hell. For the dinosaurs and other animals there was no escape. Those near the impact died instantly from the blast or the tsunami. Those farther away died in the fires. And those that survived the fires were about to face an even greater threat. The fires burned for weeks, maybe months. They consumed forests, jungles, grasslands. The amount of smoke and ash produced was staggering. All of this material, smoke, ash, soot, rose into the atmosphere, and it stayed there. Normally, smoke and ash from fires fall back to the ground relatively quickly, but the sheer volume of material, combined with the ejecta dust already in the atmosphere, created something unprecedented, a global cloud of particles that blocked out the sun. Within weeks, the sky darkened. The amount of sunlight reaching the Earth's surface dropped dramatically. Some scientists estimate that 99% of sunlight was blocked. Imagine perpetual twilight, or worse, near total darkness. The middle of the day would look like dusk. At night there was no moon, no stars, just blackness. And the temperature began to drop. Without sunlight the Earth cooled. The warm Cretaceous climate, which had no ice caps and tropical conditions even at high latitudes, began to plummet. Temperatures dropped by tens of degrees Celsius within months. This is called an impact winter. It's similar to the concept of a nuclear winter, which would occur after a large-scale nuclear war. The principle is the same. Particles in the atmosphere block sunlight, causing global cooling. The impact winter lasted for years. Some estimates suggest a decade or longer. During this time the Earth was cold and dark. And without sunlight, plants couldn't photosynthesize, they couldn't grow, they began to die. The collapse of plant life was the beginning of the end for the dinosaurs. Plants are the foundation of almost every ecosystem. Herbivores eat plants, carnivores eat herbivores. Remove the plants and the entire food chain collapses. As the impact winter set in and darkness enveloped the Earth, plants stopped growing. Ferns, trees, grasses, all began to wither and die. Some plants have seeds that can survive long periods of dormancy. Some roots and spores survived underground, but the vast majority of plant life died. The herbivores were the first to feel the effects. Triceratops, hadrosaurs, sauropods, and countless others depended on eating large quantities of plant matter every day. Large herbivores like the massive sauropods needed to eat hundreds of kilograms of plants daily. When the plants died, the herbivores starved. Within months food became scarce. The herbivores, already weakened by the cold and the darkness, began to die en masse. Their carcasses littered the ground. In some areas there may have been a temporary abundance of food for scavengers, but it didn't last. The carnivores, which preyed on herbivores, also began to starve. T-Rex, raptors, and other predators found fewer and fewer prey. They too began to die. Even scavengers, which could eat carrion, eventually ran out of food. There were only so many dead herbivores. Once those were consumed or decomposed, there was nothing left. The food chain collapsed. From the top predators down to the smallest herbivores, the dinosaurs were starving. Some may have tried to migrate to find areas with more food or warmth, but there was nowhere to go. The entire planet was affected. The darkness and cold were global. And so over the course of months and years, the dinosaurs died, not all at once but gradually, starving, freezing, unable to reproduce or care for young. By the time the skies began to clear and sunlight returned, the age of dinosaurs was over. Not everything died. If the asteroid had killed 100% of life on Earth, we wouldn't be here to talk about it. But the extinction was massive. Approximately 75% of all species on Earth went extinct. This includes all non-avian dinosaurs. Every species of dinosaur, from the smallest raptor to the largest sauropod, died out. The only dinosaurs that survived were certain bird lineages, which are technically considered avian dinosaurs. All parasaurs, The flying reptiles, some with wingspans of 10 meters, went extinct. Most marine reptiles, mosasaurs, plesiosaurs, and others died out. Only a few marine reptile groups survived, like sea turtles. Many species of fish, marine invertebrates, and plankton, the oceans were devastated. Many species of plants, forests were destroyed. It would take millions of years for them to recover. But some creatures survived, and understanding why they survived helps us understand the extinction. Small size. Many of the survivors were small. Small animals need less food. They can survive on scarce resources longer than large animals. Mammals, most of which were small and rat-sized during the Cretaceous, were able to survive by eating seeds, insects, carrion, whatever they could find. Ability to hide or burrow. Animals that could go underground had a huge advantage. They were protected from the initial heat pulse, the fires, and the cold. Burrowing mammals, some reptiles and amphibians survived. Aquatic or semi-aquatic lifestyles. Creatures that lived in water, like crocodiles, turtles, and frogs, had a buffer against temperature extremes. Water retains heat and cools more slowly than air. They could also find food in aquatic environments. Dead organic matter, detritus, smaller creatures. Generalist diets. Animals that could eat a variety of foods had an advantage. Specialists like large herbivores that needed specific plants died out, but omnivores and scavengers, which could eat anything, survived. Ability to enter dormancy. Some creatures, like certain fish, amphibians, and even some insects, can enter states of dormancy or hibernation. They can slow their metabolism and survive long periods without food. This helped them survive the impact winter. Crocodiles and alligators survived, likely because they were aquatic, could go long periods without food, and could eat carrion. Turtles survived for similar reasons. Birds, being small and mobile, able to fly to find food, and having generalist diets, survived. Mammals, small and adaptable, survived. But large, specialized dinosaurs had none of these advantages. They were big, needed lots of food, and lived on land where the devastation was worst. They had no chance. Eventually, after years, the skies began to clear. The particles in the atmosphere settled. The soot and ash fell to the ground, forming a thin layer of sediment that can still be found today in rock layers around the world. Sunlight returned. The earth began to warm. Plants that had survived as seeds or roots began to sprout. Ferns were among the first to return, thriving in the disturbed, nutrient-rich soil. Over time, forests began to regrow. The survivors emerged. Mammals, which had been small and insignificant during the age of dinosaurs, now had an opportunity. With the large predators and herbivores gone, ecological niches were empty. Mammals began to diversify. They grew larger. They adapted to different environments. Over the next 10 million years, mammals exploded in diversity. From small shrew-like creatures, they evolved into the incredible variety we see today. Primates, whales, elephants, bats, rodents, carnivores, and more. And about 65 million years after the asteroid impact, one lineage of mammals evolved into something unique. Primates that walked upright, developed large brains, and eventually created civilizations. Humans. If the asteroid hadn't hit, if the dinosaurs hadn't died, would we exist? Almost certainly not. Mammals might have remained small nocturnal creatures, living in the shadow of dinosaurs forever. The asteroid that killed the dinosaurs created the world we live in. For a long time, scientists didn't know what killed the dinosaurs. Fossils showed that dinosaurs went extinct at the end of the Cretaceous period. But why? Theories abounded: climate change, volcanic eruptions, disease, competition with mammals, even the idea that they went extinct gradually over millions of years. But in 1980, everything changed. A physicist named Luis Alvarez and his son, geologist Walter Alvarez, published a groundbreaking paper. They had been studying a thin layer of clay and rock formations in Italy. This layer marked the boundary between the Cretaceous and Paleogene periods, the KPG boundary, exactly 66 million years ago. Below this layer, there were dinosaur fossils. Above it, none. The Alvarez team analyzed the clay layer and found something strange. It contained high concentrations of iridium, a rare element on Earth but common in asteroids. They proposed a radical idea. A massive asteroid had struck Earth 66 million years ago, and the impact killed the dinosaurs. The idea was controversial. Many scientists were skeptical, but over the next decade, evidence accumulated. The iridium layer was found in rock formations all over the world, always at the same level, always marking the KPG boundary. Then, in 1991, the smoking gun was found. Geophysicists identified a massive impact crater buried beneath the Yucatán Peninsula in Mexico. The Chicxulub crater, about 180 kilometers in diameter, dated to exactly 66 million years ago. The evidence was overwhelming. The asteroid impact theory was confirmed. Today we know in remarkable detail what happened. We've studied the crater, the rock layers, the fossils, and the chemistry. We've run computer simulations of the impact. We've modeled the climate effects. And the picture is clear. 66 million years ago, an asteroid struck Earth. It unleashed a cataclysm that reshaped the planet and ended the age of dinosaurs. Could it happen again? Yes. Asteroids are still out there. NASA and other space agencies track thousands of near-Earth objects in EO's asteroids whose orbits bring them close to Earth. The good news is that we haven't identified any large asteroid on a collision course with Earth in the next 100 years, but smaller impacts happen regularly. In 2013, a meteor about 20 meters in diameter exploded over Chelyabinsk, Russia, injuring over 1,000 people from shattered glass and shockwaves. A 10-kilometer asteroid like the one that killed the dinosaurs would be catastrophic if it hit today. It would likely cause human extinction or near extinction. But we have something the dinosaurs didn't: technology. In 2022, NASA successfully tested a planetary defense system called DART, Double Asteroid Redirection Test. A spacecraft deliberately crashed into a small asteroid and changed its orbit. It was proof that we can, in theory, deflect an incoming asteroid if we detect it early enough. We're watching the skies. We're preparing. The age of helplessly waiting for impacts is over. We've learned from the dinosaurs' fate. 66 million years ago, on an ordinary morning, the world changed forever. An asteroid 10 kilometers wide struck the Earth near what is now Mexico. In an instant, it unleashed the energy of billions of nuclear bombs. The impact created a crater 180 kilometers across. It triggered earthquakes, tsunamis, and global wildfires. It threw billions of tons of debris into the atmosphere, blocking out the sun for years. The Earth plunged into an impact winter. Darkness, cold, plants died, herbivores starved, carnivores followed. The food chain collapsed. Within months, dinosaurs, the dominant life forms on Earth for 160 million years, were dying. Within years they were gone. 75% of all species on Earth went extinct. But some survived. Small mammals, birds, crocodiles, turtles, creatures that could hide, burrow, swim, eat anything. They endured. And when the skies cleared, a new world emerged. The age of mammals began, and eventually, 65 million years later, humans appeared. The dinosaurs' extinction was our beginning. One day, one asteroid, one moment, that's all it took to end an era and begin another. The dinosaurs ruled for 160 million years. Humans have existed for 300,000. In the grand scope of Earth's history, we've barely begun. The asteroid that killed the dinosaurs reminds us that life on Earth is fragile, that the planet we live on is subject to forces beyond our control, that extinction, even for the most dominant species, is always possible. But it also reminds us that life is resilient, that in the wake of catastrophe, survivors adapt, evolve, and thrive, that endings are also beginnings. 66 million years ago, the day the dinosaurs died, the world ended, and it began again.